Hello everyone, my name is Yingying, and my review of article is Urban Flood Risk Warming or the Replied Urbanization. It is written by Yang Bochen, Haolan Zhou, Hui Zhao, Guo Mingdu, Zhu Huizhou. And first, about purpose. The article was to provide a method to forecast the flood risk warming. It's called the Data Mobility Index for the Evaluation Warming Method. We also call the DMFEW method. Why forecasting the flood risk warming is important in urban area? Because due to the urbanization, most of cities don't have a better drainage system. Every flood, it will cause a lot of people die and lose a lot of the property. So the article chose the Dongguan city for a study area because it is located in southeast of China and it is in the Pearl River delta. Like this small map, there is the Dongguan city. Due to the geography and monsoon, this area is easily to happen the flood and have a lot of the population. So however, big forecasting flood warming system cannot show in the small scale. Most the forecast flooding warming system just show the Guangdong province this scale, but not easily to show the small scale like a small city. So the author was to use the DMFEW method to test the flood warming in small scale. This is the method. First, they have the 3 steps. First is build the urban flood forecasting model. Next is use urban flood risk warning model. And the next one is calculate the flood risk level. First is about urban flood forecasting model. First step, the article distinguishes the drainage system ground division, like this picture. You can see, based on first-order river system, underwater system, we can distinguish the Dongguan city to 28 subdrainage system. Then, based on spatial channel and normal channels, to make the Great Division map, like this picture. Next, calculate the data from Guangdong Meteorological Bureau. We can get the precipitation estimation value, rate of production value, surface rate of routing, and pipeline rate of routing. In order to make more clear, the article chooses the 2 time to show that. First, like this picture, it is in the 9 p.m. July 16, 2006, and this one is 10 p.m. July 16, 2006. And the next step is build and use the urban flood risk warning model. They have it requires 5 indication, like the diving force index, process index, stat index, impact index, and repossess index. Diving force is the impetus of urban flooding, and the process index in this paper is defined as the water level as a river channel that affects the urban water flow to the nearby water channels. Stat index is the floodbed depth, and the impact index. It means the impact is the result of the emergency caused by urban flooding. It is not easy to measurement. However, like this impact index, we can, due to the building broken, to measure it. Response index. Response refer to the measurement of urban flooding disaster provision. Each index includes 4 levels, like very good, good, fair, bad, depending on the criteria. Different range of value can be assessed to different level for calculation. Third step, the article uses the data from second step to calculate the flood risk level. It uses fast subtraction function like these pictures. And last, we can get the result. It is the forecast flood risk level map, like these two. Because above the picture, the first one is 10 p.m. July 16. So the forecast is 10 p.m. The above 10 p.m. So forecast is 11 p.m. And these two map, we can see the radar, the air, the here the level of the flood risk, like the legend. Yeah, and we can find the northeast of the Dongguan city, like this one, and the middle of the Dongguan city. They have the high risk level. However, some areas along the river have low level. You can see this area. Why? Because the old city in the middle of the Dongguan, it doesn't have a good drainage system. And the northeast of the Dongguan, they have a lot of industrial campus. These campus also don't have enough and good drainage system. However, area along the river in this area, they have a great drainage system and a great sulfur vegetation, so this area of the flood risk are very low. Due to this situation, the article gives us some conclusion. First, compare with the history of the 2006. Because we choose the 2006 July 16. It is the flood day, so we have a lot of the data about the population, and compare each other. There, the article finds there is a little difference between the predicted value and the actual value. Furthermore, the disaster situation in all parts of the Dongguan city is consistent with the production risk level. It shows that DMFEW math is feasible. So if it is use it, we can avoid the unnecessary damage caused by flood. So this will a lot of people die and the property loss. Meanwhile, it can also show the special difference in small scale, like this picture. This have already distinguished the 228 grade division and appear with the single. Next is appear with a single factor, like the precipitation warming mass. We can find the DMFEW mass are more accurate because it focuses on 5 factors. Last is about my idea of this article. I think this article is very interesting and useful for me to because it's for me to study my group research about the flood, and the urban draining system can be a better play based on multi-year flood risk level. like the old city in Dongguan, we can see due to the bad drainage system, they have the high level flood risk. So it tells me the drainage system is very important. So this area, like the old city, can play a better drainage system. And the last one is the reference. So this is my presentation. Thank you for listening.